So we can post this. Let's start off with number 1. And so I want to give you guys about, let's say, a minute and a half here. I think should be plenty to try out number 1. So see if you can do number 1 on your own first. Read through it. This one's multiple choice. I think it will require a calculator. So let's give number 1 a try. Ready, go. Quick reminder here, or a quick, I don't know, advice. This is the actual question. This is the actual thing we're trying to figure out right here. All right, another hint if you're still stuck, remember that this vertical line right here means given. So we would read this as the probability that you watched more than 1 hour of TV, given that you have a 6-period class. Mm-hmm. All right, so if you did not know that that vertical line there means given, I would definitely write that down like I did there, because you are going to need to know that for the test. It is in your notes, so if you're going to be using your notes for the test, then that's fine. But if you want to use this review to help you with the test, which is probably also a good idea, I would definitely have that down there, okay? All right, now we did have a formula for the probability with the given. And so if you wanted to use that, you could. And so we said the probability of A given B equals the probability of A and B over the probability of B. So you could actually use that formula here if you'd like. I always told you that with the tables, and with the Venn diagrams, it's usually a little bit easier to do this without the formula. And so how we do this without the formula is that we take whatever's after the given, and the order on this is really important. So I take whatever's after the given. So in this case, what's after the given is the 6-period class, right? And so I'm going to isolate all the 6-period class, all right? So that means for the purposes of this problem, we're only thinking about people who have a 6-period class. And so with that, I would get my denominator. So then I know my denominator is everybody who has a 6-period class. So that would be 23. All right, so then the numerator is out of those 23, and that's why I like to do the denominator first, because it limits my population here. So I'm not looking at everybody, I'm just looking at the 23 people. Out of those 23, how many watched more than 1 hour of TV last night? And that would be 13. Now, sometimes they'll leave that as a fraction, and that's fine. Sometimes they'll do it as a percentage. Sometimes they'll do it as a decimal. So you need to be able, and the only way we'd know that is just if it's multiple choice, we would look at the multiple choices, okay? So we'll do this one, 13 divided by 23. And so this gives me 0.565 on the calculator. So then I know the answer is B. All right. I mean, if it's multiple choice, you don't have to worry about rounding, right? Like just it'll be obvious which one is the correct one. So I wouldn't stress about rounding on a multiple choice. All right, let's move on to number 2 then. So it says of 100 students, 23 are taking calculus, 29 are taking French, and 12 are taking both calculus and French. If a student is picked at random, what's the probability of the student is taking calculus or French? All right. So on this one, I would say, and I'm going to give you guys a minute and a half to figure this one out. And then we'll go over it. But when it says 23 are taking calculus, that does not mean calculus only, okay? So the 12 people that are taking calculus and French, they're part of the 23 that are taking calculus, right? Because it does not say calculus only. All right, so let's take a minute here, see if you can figure this one out. They did this one as this one's not multiple choice, but I'll tell you, they put the answer as a simplified fraction on the answer sheet. So that's what I'll do. I'll also do a decimal, do both. About 30 seconds and we'll go over the answer here. But I'd encourage you to try it on your own, try all these on your own. It's like a practice test for yourself. Our actual test is going to be on Thursday. Okay, so this one involves or, it's calculus or French, right? So we do have a formula for this. It says the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. It is possible to do this problem without that formula, but I think that just makes it a little bit easier. So if you did it a different way, you may still have the correct answer. Let's see. All right, so we're trying to figure out the probability of A or B. So the probability someone takes calculus, I would say, is 23 out of 100. No, I would not count the 12 in there because, like I said, the 12 are already counted in the 23. Because of the wording, what they said there, they said 23 people are taking calculus. It doesn't say calculus only. So the 12 people that are taking both are already part of this 23. Okay. And then the probability that someone's taking French is 29 out of 100. And so once again, the 12 people that are taking both are counted in that. But you can kind of tell that we counted those 12 people in both of those, which isn't really fair to count these people twice. And so that is why we subtract out whoever is taking both here, because really those 12 people were counted in both of those fractions, okay? All right, we are adding and subtracting fractions here, but the good news is we have all common denominators, right? So we just have to add and subtract the numerators and we'll get the, we'll get the new numerator over the same denominator of 100. So 23 plus 29 would be 52 minus 12 would be 40. If we reduce that, it would be 4 out of 10, which if we reduced it again would be 2 out of 5. So 2 out of 5 is the answer they have on the answer sheet, which is on the last page here. But if they did write that as a decimal, they would say 0.4 or 40%. All right. All right, let's take a look at number 3, and I'll give you guys a minute to try out number 3. It should be really quick on this one. Take a look here, and we notice that it is asking another OR question. And so since it's really asking another OR question, you could actually use, and you should actually use the same exact formula we used last time. So it should be pretty easy here. Same formula we used last time. All right. So probability of A or B is the probability of A plus probability of B minus probability of A and B. All right, so probability of A is 0.6. Probability of B is 0.4. Probability of both is 0.1. And so that gives me a probability of 0.9, which is equal to 90%. Looking at the answer sheet, they left it as a decimal. They left it as 0.9, which is fine. All right, let's take a look at number 4. Number 4, there's a couple different ways to do it. You can see they are asking another OR question here, so you actually could still use the same formula if you'd like. I also think that if you do this one, like you can do this one logically without a formula and still get the correct answer. So I'll be showing you both methods. So whichever you kind of think works, see if you can answer number 4, all right? Okay, 30 more seconds for number 4. Definitely give it a try on your own here. See how you do. All right, let's go over number 4. So since we have the OR here, we could do this using the formula. Maybe I should draw a picture too. I go ahead and do that. So we have the spinner. We got 1, 2, 3, 4, 5, 6, 7, 8. Okay. So the probability of an even number looks like 4 out of 8. The probability of a multiple of 3, that would be 3 or 6. So that would be 2 over 8. And then we have 1 overlapping there because 6, the number 6 is both of those. The number 6 is an even number, but it's also a multiple of 3. So when I do that, I get 5 out of 8, okay? So that's using the formula we've done on the previous 2 questions. Alternatively, a different way to do this is to go through the spinner and just circle all the numbers that are either one of these, if they're an even number or they're a multiple of 3. So I would just circle all the even numbers. I would circle all the multiples of 3. I would see that after I circled 3, like 6 is already circled, so I don't need to circle that again. So like how many orange circles do I have in there? I have 5 out of a total of 8. So you could have just used that logic instead and still gotten the 5 out of 8 answer. Which way do I think you should do this problem? I think you should do this problem whichever of those 2 ways made more sense to you. Okay. I think it's a good idea to have kind of multiple ways of looking at it. And if you have 2 different ways of looking at it and they both come to the same conclusion, that must mean that it's a good chance that answer is correct, right? Okay. All right, let's move on to number 5. So number 5 and number 6, we have our the normal distribution curve. They give us the mean and the standard deviation. And they ask us what percentages fall between these numbers, okay? So I'll give you guys 2 minutes here to do number 5. And then we'll go over it. All right, so I'm going to draw my quick bell curve here. So we know in the middle, we have 221. And if I subtract the standard deviation, minus 11, that's 210. And if I do it again, that would be 199. Now I could do this to the right, but I'm not actually going to. And the reason I'm not going to is because like this is the question, right? Is between 199 and 220. So I would just make sure I had, or sorry, 199 and 210. So I would just make sure I had those numbers, 199 and 210. So really the only region I care about is this region right here. I don't even care about this one. So then I would just look at my notes and see what percentage is that one right there. Where's my notes? Here it is. All right. And my notes say that that is 13.5%. So that would be my answer, 13.5%. Now they put the answer as 0.135, which remember is technically the same thing. So I'd say either one of those is fine. When we write it as a decimal, we always move the percentage 2 times to the left. All right. All right. So next up here, once again, I'll do my bell-shaped curve. This time our mean is 125. Now they're asking about longer than 155 minutes. So I would just add 15 this time as we go to the right, because I really only care about whatever's greater than 155. And so I'll put one more here at 170. So I'm just adding 15, adding that standard deviation along the way. I really only care about these two right here because it says longer than 155 minutes. So those two would be longer than 155 minutes. All right, so I would just look at my notes and get the percentages on those two spaces. All right. So this one is 2.35%. This one is 0.15%. So 2.35 plus 0.15 gives me a total of 2.5%. All right, let's go on to number 7. Oh yeah, number 7's like the 10-parter here, not 10-parter, 7-parter. Okay, so question, we got a chart here. So we got the freshmen, sophomores, juniors, and seniors, and then do they prefer morning, afternoon, or evening classes? So then how many are in the set of senior union prefer morning classes? So remember, this one means or. And so I would add up all the seniors. So 11 plus 20 plus 20. I would then add up all the morning classes. So that would be 7 plus 11 plus 16. I would not add this 11 in again because we already counted it up here, right? So it's just these 4 plus these 2, if you want to look at it like that, or these 3 plus these 3. Just every one of these individual boxes that are either a senior or prefer morning classes, all right? All right, so we'll add all that up. And we get 85. All right, so the next one is how many students are in the set, seniors and prefer morning classes. So I'll give you guys 15 seconds here to get that. All right, so this one is just 11. So just these 11 students right here that were both seniors and preferring morning classes, all right? Okay, next question. What is the probability someone prefers morning classes? And we got the vertical line again. Remember, that means given that they are a junior, okay? So this is a lot like the question we did, first question we did today on this. So I'll give you guys a minute to try this out. I'm going to leave my answer as a fraction here. So what's the probability someone prefers morning classes given that they are a junior? All right. So prefers morning classes given that they are a junior. So we'd isolate all the juniors. So I'm looking just out of these ones right here. So that's going to be my denominator. So that'd be 16 plus 3 would be 19. 19 plus 18 is 37. So then out of those 37, how many prefer morning classes? That would just be the 16. Remember on those ones, the order does matter, correct? So whatever's second, whatever's after the given, that's your denominator. That's what you isolate, all right? So if you kind of did that the other way, if you added all these up for your denominator, all the morning people, that is backwards. That is going to give you the wrong answer. Your numerator is probably correct, but your denominator will be off. All right, next up. What's the probability that a randomly selected student from the whole group is a sophomore and prefers afternoon classes? All right. So I'll give you guys a minute to figure that one out. I think knowing the total for the whole table is helpful for this question. So I did that. I got 180. So then if we want only sophomores who also prefer afternoon classes out of everybody, there are 20 students that are like that, these 20 right here. So we would just reduce that to 2 over 18, which would reduce again to 1 over 9. All right, next up, what is the probability that a randomly selected student is a sophomore or prefers evening classes? So this is saying out of everybody again. So I already know my denominator is going to be 180. So then for the numerator, we need sophomores or preferring evening classes. So why don't you guys try that out? I'll give you a minute here. All right, so what is it? Evening classes or sophomore, right? So it'd be all of these people. All right. So that is 11 plus 20 plus 17 plus 17 plus 18 plus 20. So that gives me 103 out of 180. All right, why don't you go on to part F? What's the probability that the student's a junior given that they prefer evening classes? All right, so if we're just looking at the people that prefer evening classes, it's all of these people right there, just the bottom row. And so our denominator is that whole bottom row, 17 plus 17 plus 18 plus 20. And that adds up to 72. And then the numerator is out of all that row only, how many are juniors? So that would just be the 18 there. The juniors. And if you divide those both by, actually they both divide by 18. I'll do 9 though. If you divide them both by 9, it would be 2 over 8, which would then reduce to 1 over 4. All right, last up here, and we'll finish up with this one. What color? Pink. All right. What is the probability that a randomly selected student prefers afternoon classes? So we already said the total was 180, right? So I know it's out of everybody here because there's no given. And so then the numerator is all the people who want afternoon classes. So all these people right here. Yeah, 20 plus 20 plus 3 plus 20, that looks like 63. that does reduce by 9, right? So that would be 7 out of 20. Awesome.